Okay, we're going to be looking at area and perimeter and the coordinate plane, and I'm going to do kind of an easy example so it goes as quickly as possible in this video. But let's say you have something like this. Well, the problem here is you don't have anything perfectly horizontal or perfectly vertical, so nothing can really be counted, right? Whereas if this were sitting on the coordinate plane where this were horizontal and this were vertical, then it would be really easy because we could just count. But because it's this diamond shaped, then we are going to have to find the lengths for area and for perimeter using another method. And so we've talked a lot, so I hope you kind of got this cemented in your head by now, that we can find a diagonal distance by creating a right triangle off the side of this and making the side of the figure a hypotenuse. Okay? So I create a right triangle. Sorry, hang on, guys.
The empowerment meeting will not be held today. It will be held on Wednesday. Once again, empowerment meeting will be held Wednesday due to the inclement weather. Thank you.
Okay, so if we create a right triangle off the side of this figure so that it becomes the hypotenuse, then we can do a squared plus b squared equals c squared and find the length of it. So this is 1, 2, 3, 4, 5, a length of 5, and this is 1, 2, 3, 4, 5, a length of 5. I created a square because I'm lazy. Then I can find this length right here by simply going 5 squared plus 5 squared equals c squared and solving for c. So this would be 25 plus 25 equals c squared, or 50 equals c squared. Then I can solve for just plain old c by taking the square root of both sides. And if I take the square root of 50, I'm going to get 7.1. So that tells me this side is 7.1. Now, if I suspected these were different lengths, what I would do is for each different length, I would just create another right triangle. So let's say I think, okay, maybe these are different lengths. I'm going to create a second right triangle off of it. You can see here, where now this side of this is the hypotenuse, and this is my A, B, and C. So now we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we're looking really at the same problem as this because it's 5 squared plus 5 squared equals c squared. So in that case, it's 7.1 again. And it turns out in this picture, only when it's a square though, not a rectangle or any other shape, every single one of these right triangles that I would draw off of here would be a 5 by 5 right triangle with a hypotenuse of 7.1. So right here you can see it again. This is 5 and this is 5, so this has to be 7.1. So if this picture were asking for the perimeter of this original shape, which was this square right here, then I could just add 7.1 plus 7.1 plus 7.1 4 times. Now remember, that's perimeter. How long is the distance all the way around? Or I could do 4 7.1s because it's a square, and that would give me a perimeter of 28.4 units. Okay. But if it's not asking for perimeter and it's asking for the area of this figure, so let's say it wants the area. Well, to find the area of this figure, it's going to be base times height. Well, I just need to pick a base. So because this is the base, if I tilt the picture, this is the base, this is the height. If I tilt the picture, this is the base, this is the height. Again, this is a square, so base and height are going to be the same no matter what we're talking about. So in this case, my base is 7.1, my height is 7.1. Of course, if this were short and this were long, right? Regardless of how I tilt it, that's what we're going to end up with. So we do 7.1 times 7.1, and we end up with an area of 50.41. I hope that helps.